Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. And in the previous lectures, I discussed the conversion between Java types and native types. And we also saw that how objects are mapped. So we looked at the primitive arrays or arrays of primitive types in Java, which are basically objects in Java, and they get mapped to the primitive type array, which is a object in C++, or an object pointer actually in C++. And we also looked at a general case of object arrays. So these objects are not primitives. For example, an array of a string is an object array, right, in Java, or a two-dimensional array in Java is an array of objects, and each object is another array, right? So we looked at these and we said that we have to work with the JVM to get the information that we want, right? So this environment pointer was the essential key. And now I want to look at a little bit at the strings, Java strings, and it's more or less the same story. If we want to pass strings from Java to C++ and from C++ to Java, because the type mapping is not direct, strings are objects in Java. Strings in C++ have kind of two types of representation, C style string or C++ style string. So there is no direct mapping here. And then again, because of that, we have to ask our JVM, this JNI environment pointer, which is our JVM, to kind of give us the information that we want. Okay, so strings in Java is an object with UTF encoding, right? And a string is an object in java.lang package. So its signature as an object is L java/lang/string semicolon. So each object has a signature that starts from L and ends with semicolon. All right, so L java/lang string semicolon. And if you recall, when we talked about the operator overloading, we said that the slash becomes underscore, semicolon becomes underscore 2. So that's when, for example, we want to override or overload a native method with a parameter that has a string, then this underscore signifies an overloading of native methods. And then the method parameter signature, if it includes a string, then we have to use L java underscore lang underscore string underscore 2, because semicolon becomes underscore 2. And then yes, I wrote them here. So a slash is replaced by underscore, semicolon is replaced by underscore 2. This square bracket, which signifies arrays, is replaced by underscore 3. And we said that the underscore itself, if it's in the name of the method or name of the package or class, so underscore in Java name becomes underscore 1 in C++ function signature. Okay, so this is just to refresh your memory. And now, so a string is an object in Java with a UTF or character encoding of UTF. And the char data type in Java is 2 bytes, not 1 byte. It's 2 byte unsigned. So it's 16-bit, a 16-bit unsigned integer type character. But in C++ or C, character is only 1 byte and it's unsigned, okay? And so 1 byte 8 bits, in Java it's 2 bytes. And the encoding in C++, I believe it's ASCII, so that's why we have like 1 byte. In Java it's UTF, which requires 2 bytes, more than 1 byte. And as we mentioned in this table, character type, the data type in Java, gets mapped to a JChar type in native or C or C++. And this JChar was actually a 16-bit unsigned integer. So I have it here. So if you look at the JNI.h header file, JChar is mapped to unsigned short. Short is an integer, a signed integer, which is 2 bytes signed, but JChar, we want it to be unsigned. That's the mapping between native and Java. Java is 2 bytes 16 bits unsigned integer. That therefore in the JNI header we have the jchar defined as a unsigned short. Okay, 2 bytes unsigned integer. And the strings are in C++. They basically have 2 types of representation, and the char data type is 1 byte unsigned in C++. So let's write this here. Character is unsigned. And then C style string literals are char pointer and array of characters. And we can always use the size of method, size of operator or size of method to find out what is the size of a character in C++. But then we also have the C++ string object. So it's a C++ string style basically object. And it's in the string header. And again, it belongs to the namespace std, so the standard namespace. So the std : string defines a type, a class, an object, right? That is actually very similar in behavior to the Java string. So most of the methods are more or less similar. So you can also use this. And the operators are overloaded for this std string, which means you can concatenate two std strings just by plussing them, adding them together. Very similar to Java again. And if you want to find the length of a string, then you have to call the string.length, something like that, to get the length. Again, very similar to the string. And there is also a method to convert the string style to char style. The reason is that the JVM doesn't directly deal with the std string. It only deals with char pointer. So it only deals with C style string. So if we want to do the conversion, I believe it's like a string.cstr, something like that. So this method converts a string to a char pointer, const char pointer. And these are constant string literals are basically const char pointer. So this method is also handy if we want to do our operations on the std string and then eventually convert it to char style. Okay, so this is something that we can have in mind when we're dealing with the strings. All right, so how do we work with the strings between Java and C++? The types are completely different. So again, remember that Java only works with the heap memory area. Every object, every string that we create, they are created on the Java heap. And we have something called a string internalization, which keeps the string literals in a constant pool. And then different string objects that have the same string literal are pointing to the same string literal in the string pool. That's some sort of optimization that the JVM does in order to not create many strings that have the same value. Okay. So string objects and string literals are on the heap, and we have, so as I mentioned, we have something like a string pool, which we don't really need to care about this. Maybe it's just for your information to know that we have something called a string internalization, and there is a method in a string called intern. So we have the string.intern method in Java. And this basically tries, if you create a string object with a new keyword, you can use this to actually add that string to the string pool, to the constant pool. Okay, because remember, in Java, whenever we use a string, create an object with the new keyword, the JVM 100% will create a new object on the heap. But if we use string literals, and we assign the same string literal to different Java strings, the JVM actually creates one string object, puts them in the string pool, and points the two string objects to the same string value or a string literal on the string pool. So that's some sort of optimization that the JVM does. All right. So the bottom line is this: in order to create or access Java strings in the native code, in C++ code, we need to deal with JVM. We need to ask JVM. And how do we ask JVM? We use the JNI environment pointer, the env, right? And that's the main thing. So the important methods in that we can ask JVM when we are dealing with strings are these. One is for creating a new Java string in C++. In the native code, we ask an environment JVM and use the new string UTF, because remember, Java deals with the UTF encoding, so new string UTF, and we pass in a string literal. And a string literal in C++ is const char pointer. It's an array of characters and it's a constant array, right? And then this method returns a reference to a JString, and JString is a pointer, is a reference. Java deals with references, and a reference in C++ or in native code is a pointer to an object, to a JString object. So this JString is a reference, a pointer. Okay, so this is how we create a new string. So here we say, okay, JVM, create a new string on the heap. Remember, this thing will be put on the heap because Java only deals with the objects on the heap, and then returns back a pointer to that object on the Java heap. Accessing an existing Java string. If we have a Java string already in the Java heap, we can say JVM environment, get a string UTF char, get the characters of that string. And this str is basically a JString. Let's write it JString. And then there is another parameter, is copy. So this is copy is basically a JBoolean object. And then so either JVM creates creates a copy. This is a JBoolean. I believe it's a JBoolean pointer. Okay, so either JVM creates a copy or returns a copy of the existing string, or creates a new string and returns it to us. And what does it return? Again, we're getting the characters, so it returns a const char star. So it's a character array. Okay, and remember, this is a C++ or native basically native reference, C++ pointer. This is not a Java pointer. This is not like a JString or JObject or JArray. This is a native pointer, and JVM creates this array of characters and puts them on the native heap. And when something is put on the native heap, the garbage collector doesn't really clean it up. Garbage collector mainly deals with the Java heap, right? So we have to be careful here, because now we need to manually, whenever we're done with this character and we're returning back to Java, we need to manually free the memory, the native heap, from this array of strings. Okay, so if we want to release a string, environment release a string UTF, and then we pass in the JString reference, the Java reference, and also the basically const char pointer. Let me just write it as a char star. Okay, so this is the actual character array, the native character array that has been created by JVM on the native heap, and we have to manually release it. With this reference, we pass in the memory address and the actual value, and then the JVM just releases this native heap, and basically the memory is freed up. Okay, so dealing with strings is simple. One problem is that we don't have direct access from JVM to this string. So JVM methods only deal with this character array, which is a C style string. So, but the good news is that the assignment operator for the std string is overloaded. So if we use a std string and use an assignment from the char star to the string, it automatically does the conversion. And eventually, when we are done with the operations on the std string, we can use this cstr to request a character array char star from the std string. So I always prefer to use to deal with the std strings. So let's head to Eclipse and try to work with the Java string. So in the basically our workspace, I have this native, which is a Java project, and then native C, which is a C++ project. And right now I'm going to the Java perspective here, and then I'm going to create a new package. Let's call this test6, and here I'm going to create a new class, and let's call it test string. Let's have a main method and finish. All right, so now we have this. Let's see what we want to do. So obviously we want to create native methods and then load the library, this libnativec. So I'm already adding the static initializer system load library, and as I mentioned before, and I'm going to mention it again because this is important, we basically remove the lib. We drop the lib from the beginning of the name of the dynamic library and also the extension. So here we have native C. All right, whenever we use the load library, basically we drop the lib from the beginning. So we are loading the library, but what do we want to do? So the first case, or let's call this case 1, is just creating Java string in C++ and returning to Java. So let's have public native string say hello, for example. So the parameter is void. We're not passing anything to the C++. We're just saying that, okay, return an string and say hello. And obviously we want to return something like hello, hello world, right? We want to return something like this, which is a Java style string, and then creating in C++ and returning it into Java. So I'm going to instantiate one class, one object of this. Let's call it test, new test string, and then a string str test say hello, and obviously we can use the sysout and str. All right, so what is the step 2? So this is our Java class. Step 2 is select the Java file and run the Java H or Java C-H, whichever you prefer, and it creates the header file. I have already configured my Java H to put it in the header folder of the C++. So I'm going now to the C++ perspective. We have this header folder and the source folder, and test6 is the header file for this test string class. Test string in the package test6. The method is say hello. The signature is no parameters, empty brackets. The return type is ljava/lang/string semicolon, which is the signature for Java string. Okay. And again, to refresh your memory, the signature of the C native method or native function is Java underscore package name underscore class name underscore method name. There is no underscore, which means this native method is not overloaded. All right, so the next thing we do, we go to the source folder and create a source file. I'm going to call it a string underscore c.cpp. And the first thing I need to do, I need to include the header file so that the JNI.h file, the JNI header file, is also included in this compilation unit in this CPP file. So it's a relative path, so I use double quote ... which means go one level up from wherever you are right now. We are right now in the source folder, so we go up to the native C, and then / go to the header folder and test6. Okay, and now what I'm going to do next is to go to the header file and copy and paste this method, and JNI environment is environment, and the J object is test string. All right, these are just the parameters. There's nothing else. So what do we want to do? We want to create a J string and return it. So J string str, we are going to ask JVM to create this string for us. So environment new string UTF, and we have to pass in a const char pointer UTF, which is basically a C style string literal. So I'm going to write this here, C style A string literal is basically const char pointer. It's a character array which is constant, so it's a string literal. So hello world. All right, so we are creating this J string and then we are returning it str. And remember, the return type is J string, and this J string is a reference type, and it's a pointer to a J string object. And note that here we are not going to release the memory for this string, because we are returning it. We still need it in Java. We're returning it to Java, right? We are not finished with this string. So JVM creates that, and then we return it to the Java. So I need to compile this. The compilation is done. The native library is now created and updated with this method. I'm going to copy and paste it to our JNI folder here. And then if I go back to the Java and run this should work. Hello world, all right? So we are creating a string, a Java string in C++ and returning it as a Java string to basically Java. So we take a string literal, and I could also do this const char pointer text. So I create a string literal and then pass this to the C++. Okay. And then if I run this again, it works. Oh, yeah. But as I mentioned, it's always better to use the C++ string, which is from the std string. And in order to use that, we need to include the string header file. All right, string. We don't need the .h. So if I click it, I can find it. And as you can see, there is the namespace std. So a string belongs to the std namespace. So if I want to use the C++ style string, and that's basically std, a string object. So how do I use that? Instead of const char pointer, I create a std, a string str or text, which again we can directly assign a string literal, which is a const char pointer, hello world, right? So this is an overloaded operator. The assignment operator is overloaded. So if I go here, basically if I look at the string header file, operator minus, equality, not equal, and then what other operator, plus, has been overloaded. Basic str, greater than equal, plus, I'm trying to see if I can find the assignment. But as you can see, almost all the operators, plus, greater than, less than, not equal, equal, these are all overloaded for the std string, and also the assignment operator is overloaded. So we can directly assign a const char pointer, which is a string literal, to a std string, and then I can say return environment, create a new string utf, and then, but as you can see, we need to pass a const char pointer, so we cannot pass a std string. So if I pass std string text, I believe this does not compile. Yes. No viable conversion from std string to const char pointer. But we can call the method basically cstr. And what this cstr does is it returns the basically data. What is this data? This data is basically the array of the characters that we have. So if I do this should work just fine. So this compiles, and then if I copy and paste the new dynamic library to Java and then go here and run it again, this works. And this time I'm using the C++ string object. Okay, So this is the first thing. The next thing that we can do, let's say case 2, we want to so here we created in case 1 we created a string in C++, a Java string in C+, and return it. Now let's say we want to basically we want to pass a Java string to C++ and do something with it. Alright, let's say we just want to print it. So public native void print ln a string text. So we are passing a string, Java object a string to C++. Why? Because this is a native method, and we want to just print it with a new, and then go to the new line, print new line, print line with a new, okay, print ln. All right, so we need to select the Java file, run the JavaH again. Actually, we need to save this first, and then run the JavaH to update the header file. And this new method is now added. We go to our CPP file, and this is the println. So environment JObject is a reference to the current object, and JString, let's call it JText, which means this is a Java style text. All right, so what do we need to do? We need to print it, right? So I can say basically printf and then %s with \n, and then I have to pass a string, but this is a C++ string or const char pointer C style string, right? It's not a Java string. So if I pass JText, this should compile because this is a memory address. JString is a pointer, so it has a value, and the value can be converted to a string. So if I compile this, it works fine, and then yeah, it gives us a warning that this type is not actually a string, it's something else. But again, it compiles and it creates a native library. So let's copy and paste it to Java and see actually what Java shows. So if I use sysout test println str, so I created this str. Actually this does, okay, so we just do the print test println str. So we created this str Java string in C++ and we return it back to Java, and now I'm sending it to C++ again to get printed on the console. So let's run this, and you see it's a very weird something, right? It's not the actual text, it's something else. That's just because what we are actually printing here is a basically a long integer, right? Memory addresses in a 64-bit machine, which my machine is 64-bit, are 8-byte integers, long integers. So this is something weird, okay? That actually makes sense because each character in Java is 2 bytes, 2, 4, 6, 8. So this is 8 bytes, right? So what should we do? Again, we need to convert this Java string to C or C++ style string, and for that we ask the JVM. So environment get a string UTF chars. So this returns the characters JText and isCopy. We don't really need to worry about this isCopy, but we can create a JBoolean isCopy, and note that this one JBoolean isCopy, and then this takes a JBoolean basically pointer, so we pass in the address. So it returns a string. So what does it return? It returns a const char pointer. So it returns an array, a pointer to an array of characters that the JVM creates and puts them on the native heap, right? So const char pointer text. All right, and then obviously I can also, so I can print this text now, because this text is now in the style of the C string, the native string, so we can print it with no problem. And then I also can printf basically %s \n is copy. So let's compile this. Compiles fine. Let's copy this to Java and then go to Java and try to run the code. So JVM crashed. I believe this is the problem, so I'm not going to look at the is copy. But so let's compile this again and copy the native library to Java, and let's run this. So this works fine. All right, so we are passing this Java string to C++, and then we ask JVM to actually convert it to a native string, and then we print it to the console. All right, now obviously this was a const char style char array, right, which is a C style string. So I always prefer again to use this std string, which is a C++ style. So what I can do, I can just directly assign this whatever this method returns, get a string UTF-chars, because it's a character array, to a std string, right? String text is environment get a string UTF-chars, and JText we don't care about, is copy, it doesn't really matter. And then printf %s \n. So let's also write something like printing in C++. So let's compile. It compiles fine. And okay, we forgot to basically set the text here. So it is complaining. Why is this complaining? All right, yeah, so we need to pass in again C, the basically a constant, the char star character array. Printf, again, it's from C, not C++. So I guess instead of using printf, I mean, I could use printf here, but then I have to call the cstr, which the compiler already is suggesting we should do that, because printf only deals with the C style strings. And if I copy and paste this to Java, and now if I run this, again, this works fine. But then I can also include the IO stream and use the include IO stream, and then use the std out, right? So std C out, and then push the text to it, and then push the std end line. So I can do that. This should work fine, because again the operators are overloaded for the std string when we are dealing with std C out. So it has no problem converting this object into the character array and push them using this insertion operator into the C out. So we compile this, compile is fine, and then if I run the Java, it works fine. But personally, I prefer not to use the IO stream because it's a very heavy file. It's an extremely heavy file, and I just prefer to use the printf because it's a built-in file, so built-in method function in C. We don't need to include the IO stream. So you can just directly call the cstr, C string, on the std string. So basically what we do, we convert the std string into a C style string, which is a const char pointer. So this was case 2. What is case 3? So let's say case 3. We want to, let's say, concatenate two Java strings, and return the result back to Java. So we want to pass strings to C++, do some operations on them, and then pass them back or send them back to Java. So in the first case, we didn't send anything to C++. We just got the string back from C++. In the second case, we are sending something, a string to C++, but we're not getting anything back. In the third case, I'm going to say public native string concat, a string str1, a string str2. So I'm sending strings to C++. I want to do some operations on them, and I want to get a string back as a result. All right. So let's save this, select the Java file, and run the Java H to update the header file. And now we go to our CPP file. Environment env JObject is test string, and JString JSTR1 JString JSTR2. So again, I want to work with the std string. So std string str1 is environment get a string. Remember, these strings str1 and str2, these two are already on Java heap, so JVM has access to them. So we just say, okay, JVM environment get the string utf chars, get the characters, basically get this Java string and return it as a native or C or C++ character array, right? So JSTR1 is copy, doesn't matter, okay? But then this returns a C style string, const char array, all right? And basically this returns this string, and I'm assigning it directly to the str, all right? And then but maybe it's better to, let's say, const char pointer basically text1 and text2 JSTR2 and std string basically str1 is text1, and then std string 2 is text2. So again, assignment is already overloaded for the std string when we assign it to the const char pointer. But then what I want, std string str concat is str1 plus str2. So that's one of the good things about std string, about the std string, because the plus operator is overloaded, so we can immediately concat them. And now that I have this, I'm going to say return environment new string utf. Now that I have the native string, I just say JVM create a native create a Java string with what? With std concat, but I need to convert it to the C string, so const char pointer, right? But there is only one thing, is that JVM is creating these pointers, character arrays on the native heap. So before finishing up, we need to release the native heap for these character arrays, right? So I'm going to say environment, which is JVM release a string utf chars. So the reference, where is the memory address, is JSTR1. This is the memory address of the Java string, and what is the actual array is text1, okay? And we should do the same thing for the second string. All right, so we have to manually release this from native heap and then return a new string or a new Java string. Again, when we are creating new Java string, we should not release the memory from it, because we just want to return it back to Java and it should be available in Java. But whatever character array we put on the native heap, we have to release it. And it's actually the same thing here. So I actually forgot to release this basically. So maybe here we should also try to const char pointer get the array, which is C array, character array, and then assign it to, actually we don't need that, we just use the C array and put it in the printf function. All right, But then when we print it, then now we're done. We're going to return back from to Java, so we have to release it. Environment release a string UTF chars. And what is the memory address is the J text, right? This J string. And what is the array is C array. All right, we need to release it. Okay, so it compiles fine. Let's copy and paste the dynamic library to Java, and I'm going to say sysout test.concat hello with a space, and then world with 2 exclamation marks. So let's see if this works. And this works, printing. Okay, so it's this one. So you see what happens here? We have this print line, which prints from in the native code, prints to the console from the native code using this printf. But I mentioned this in the previous lectures that the IO streams of Java have always precedence on the IO streams of C++ when we are using the JNI. So IO streams of Java have precedence on IO streams of C++ in JNI, which means if I print something in Java and then print something in C++ and then print something else in Java, first all the prints in Java get executed, and finally all the prints in C++ get executed. So I can show you this by copy and pasting the bits print line again. So cprint plus this, and then cprint1 plus this, and then cprint2. So let's run this again. As you can see, cprint1, cprint2, these two come last. First, all the Java prints, Java system.out.println, all the Java IO streams are executed printed to the console, and then whatever is printed in the C++ to the console is getting printed. So just you need to keep this in mind if you want to print to the console both in C++ and Java. So I'm going to also copy and paste this print line again and run this. And again, as you can see, all of these printing in C++ come last after the Java prints. So I hope you enjoyed this lecture, and now you have a good understanding of how to work with strings using the Java native interface. Please stay tuned, and I'll see you in the next one.